Okay, so in this video, we're looking at uh, the request module. So request module means our Python code can request a web page. But in this example, if it only gives us a web page and does not give us a nice JSON object, we've got a lot tougher job, right? Because it's all that HTML, JavaScript, CSS. There's all these codes in that page. There are more codes on the page than useful data, and we get to figure a way to parse around it. And again, this video is just a bare introduction to that, and you could go much further if you want. So we're gonna request a web page. I'm going to take a little look at HTML so we see what's in that web page. And then we will look at Beautiful Soup. Beautiful Soup is a module that helps us navigate the HTML tags in a web page. Again, if a web page gave us data as a JSON object, we'd much rather use that data. But if the designers of the web page really intended it to be a human readable web page, it may not have a JSON object. That's up to the designer of the web page. And Beautiful Soup is the way to just kind of paw through that web page and find useful data. So it's really a very tedious process because the web page was not designed for that purpose. But this is a way, a way to sneak in and get information from pages that were not designed for this purpose. All right, so let's take a look at it. I first just mentioned HTML, and I mentioned that because HTML is the basic structure of the web page. So here is, if I double click on this cell, and quick reminder, right? Our cells can be that markdown language that I usually use with the pound signs. But a cell can also be HTML. HTML is allowed in a cell. And so what you see on the left is HTML, and on the right is the results of that HTML. So all HTML5 documents are supposed to have the first line as doc type HTML. But it may be followed by, this is an HTML comment, right? So the pound sign was it was a Python comment. This is an HTML comment. Tags in HTML have beginning and ending tags. So this is the beginning HTML tag that matches up with the ending HTML tag, and that's the content of the page. And then the HTML tags are divide the page in half, the head and the body. So here's the beginning head, the ending head, and a title tag can be in the head section. And the title tag is what gets printed up here on the tab of your web page. So that's how you put that. The body is what's displayed in the main browser window of the web page. So here's the begin the body, end body. H1 is a high level heading. A P tag is a paragraph tag. So everything displayed on the screen should have beginning and ending tags surrounding it to show that information. This is kind of the most simple, web page you can have. Real web pages are quite long because there's a whole ton of style sheets for formatting in there and different codes. And usually a web page is not like I hand wrote this web page, but usually we don't. We use web page editors. Well, web page editors might copy and paste in there huge amounts of background text that help with the formatting. So real web pages have a lot more than this, but it gives you an idea. The main point here is, well, first of all, a web page is a hierarchy of HTML tags, and you have to find some way to manipulate it, and that's what our beautiful soup is going to help us with. Okay, so this is what we get back from our request. I'll hit escape, and that cell will go away. Request library we talked about. So we call this web scraping. When the web page does not have a JSON object with data, and there's not going to be really a rhyme or reason for this to work because the web page was designed to make it look good in a browser, not accessible as data. Okay, so um, here's an example of a URL. Went to the archive again. Let's see. Here's my imports. So here I'm importing the requests that you've seen before. From BS4, I'm importing Beautiful Soup. So Beautiful Soup is a module, a ton of stuff in that module. If you get into screen scraping, you'll want to use it. You'll want to go into a lot more depth in it than we get to in this course. In this course, Beautiful Soup could be a whole course. And it's probably not your main job function as a business as a data analytics person. But if your data analytics needs some web information, you want to know this is here, I guess is more the main thing. But we won't have time to become experts in it. So we've got a URL. We get a response like we did before. Like I kind of recommended in the other video, check if the response code is 200, because if it's not 200, there was something wrong. We didn't get the web page. Okay. And here is the information from that web page. So this is just what basically we were just using the requests module, and it can print out some of this basic information about the web page. So for key and response side headers, we're printing out, that's like going through a dictionary with each of the keys, and um, we're printing the key here. Okay, that's just using the requests module. What Beautiful Soup does, Beautiful Soup converts a web page. So that's a request module. This my HTML, we've hard coded a string with a simple web page in it so that we can to make it easier to follow. This is right. My HTML is what we would get back um, from the web page, and we basically want to turn a web page or an HTML document into soup. Soup is an object type defined by Beautiful Soup, but once we convert the web page to soup, then we now have an object that has lots of attributes and methods that we can ask it, right? There's no web page object. So, we can't say, like, what's the head section or a web page. You'd have to search through the text. So this is a text string with a valid HTML page in it, and we're going to turn it into soup so that we can use the Beautiful Soup methods and attributes on that. So the web page object, my soup, Beautiful Soup is the function that takes as an argument a web page. So you could have gotten that from from the get function, but I just hard coded a small one so we can see it. And HTML parser just means, so Beautiful Soup has the ability to parse things different than HTML. So in this class, we're just using HTML, so that'll always be HTML parser. But you could have other things. You can have XML and some other things in there. Okay. And then print my soup dot head dot text. Look at the syntax. So my soup is the soup object. I create a soup object. The first attribute of the soup, there's a whole bunch of attributes. We're not going to go. But when I say dot head here, my soup dot head, that head is referring to the head HTML tag. So this head and this go together. And if I print the text, so the dot text is the text of the tag head. So that this is line 32 is very important to kind of how soup works, right? And see down here where it says title of the document was printed here? That came from line 32. Print my soup, the head tag, the text part of the head tag is title of the document. The reason that's true is the text output is just this. So text means kind of what will be printed on the screen, not including the internal tag. So the ed tag, what text is in there, title of the document. So that's an important syntax of soup. Um, Now we go down here, and so the um, HTML tags are hierarchical. So it's possible to ask what the child of a higher level tag is. So in this case, we're taking the body. So we take here, you know the so you know the for loop goes through each piece of an iterative object. So first look at what is the iterative object. My soup dot body dot contents. So um body is referring to the body tag. It refers to everything between the begin and the body. And the contents is a list. Basically, it's a list of all the tags within the body. If we had said text, it would have been just literally the text part, and we wouldn't be able to discern between an H1 to P. That would have been lost. But with contents, we're saying everything in the body is in here, and they are in separate pieces by the tag. So for this child means go to the body tag, take all of the contents, and iterate through each tag you find that's in the body tag. So here you'll say all the child tags in my body tag. That's what's printed out in this for loop. So the first one is H1 high level heading H1, right? So within the body tag here, H1 is your first child tag. Here's where it gets a little confusing. The first child in the body tag was a blank line. So see how line 16 is body, line 17 is a blank line. Line 17 is considered the first child. It counts a child as a blank line. So you would have to write into your for loop, you might say, if this child is a blank line, it's not meaningful to me and don't use it or something like that. So that's why Beautiful Soup is exciting because it gives you a way to navigate the HTML document. It remains web scraping remains a little bit annoying because you're going to get blank lines and you're going to have to write code that figures out, well, if we go through all the tags, which are useful to me. And of course, this is a simple example and it'll get worse. So it's a real art to understand what's in that web page and how I can navigate it and find useful data. And of course, the web page changes over time and then your code will break. But um, so here in this example, right? So I wanted to go to my Epicurean. I'm going to my Epicurean thing here. Say I want to find the A tags. So in HTML, an A tag is a link to another page. Well, one thing you might want to do is if you're navigating a website, you might say, hey, give me a list of all the web pages that site references because maybe they would be interesting to my research and I might search all of those pages for something too, right? Right. So obviously the web is a web, right? And so any page you pull up is going to have links to other pages. In HTML, we call that an A tag. And you might make want a list of those to see to do some analysis of what pages are referencing other pages. That's what's going on here. Um, So we get a soup response. We take the response dot text from, so the response dot text here is from the Epicurean um, archived web page. Response talk, we take the response. So this is the response from the get, right? So our get gets us a whole web page. The text attribute of the get is just the text of the page. But text here, right? A little different than the other text. It depends if you're using the get text or the soup text, but get text is all of the text, including tags and CSS and JavaScript, and we run that through the HTML parser in beautiful soup, and it gives us a soup object. So we're back to a soup object here. Soup objects have the advantage of you being able to uh, uh, use that page based on the tag information. So look what's going on here. Line 24 is critical. For an A in soup response dot find all A, right? So again, for loop, iterable object, right? Soup response find all, really important method. Find all finds all instances of a given tag. So find all A is find all A tags. So this whole thing, soup response dot find all A, think of that as a list of A tags, right? So a list of A tags with a for loop and A means it's going to go through each A tag one at a time. And I just printed out each A tag for you to show you. So this is how you would make a list of all the A tags or all the links in a page. And you could, now I'm just printing the A tag. You could read the A tag, decide maybe you're looking for A tags to a certain URL or a certain site, or might be something only certain ones you want, and you could put an if statement in this for loop or whatever. And here's the output. Look, so this is the format of an A tag, right? Begin A, and it has all this information. It has, if you look in the A tag, you'll see href equals a string. The href equals string, that's the URL of the link, right? And so you can make a list of URLs used by this site. If you just wanted the domain names used by the site, you could use string manipulation to cut this off. But again, no simple answers. A lot of string manipulation probably to find what you want. There's all the A tags. In my next example, I decided I wanted to make a list of all article titles in this issue of rollingstone.com, right? And what I did is I got my requests and my beautiful soup. My URL is, this is just the high level URL to Rolling Stone magazine. Uh, I do a response. I do my get. So now I've got my response is now uh, the string that holds the entire web page, or it's everything we got back from the web page. I check my status code. It's 200. Great. If it's a 200, that means I have a valid web page. And then I make a soup response. So I turn my response.text into soup. Um, and here's what I do. My goal is to find every article title on the web page, maybe so I could say, hey, is it worth me going to look? Let me just have a list of titles. I might put those list of titles on my webpage. I might put them in my database. I don't know what I'll do with them. So for I in soup response find all A, again, I is, I've got a list of all A tags. Well, I know, now I kind of knew that, I know this from kind of looking at the page. You might have to look at the page first to see what works for you. This might not work on another page. But I know that every article is in an A tag because the home page does not have the article itself. It has a link to the full article. So I know every article needs a link. So I know every article needs an A tag. So if I do for I in soup response find all A, that's a list of all A tags. Some of those are going to be articles and some are not, right? Because some of them are the web page manipulation, like uh, go to homepage or something like that. So for I and soup, that's all A's. This is something I discovered from reading the page. If class in I attributes, right? What's an I dot attribute? I is an A tag, right? Soup, it's a soup object, right? These are all soup objects at this point. I is a soup object representing one A tag, and the that has attributes to it, right? Let me come back to here. This is an A tag. Class is an attribute of the A tag. Class equals Condé Nast. Totally unique to this web page. This is not a standard, but all of these things within your A tag are attributes of the A tag, and every website is different. I found that on this website, uh, they all titles of articles have a class attribute. So here, I check um, does the A tag, so I is the A tag, the if class and I attributes, that is saying, does the A tag have an attribute class, right? So attribute class is not required of an A tag, and if there wasn't one on the web page, it would simply be blank and wouldn't show up here. And some of this would fail. I want to write code that assumes there is an A class. So first I check if it even has a class attribute. If it does have a class attribute, then I say, does that class attribute equal the string C title link? Again, C title link does not make sense, doesn't have to make sense. It's what the web designer said. Every title link will have a class equals title link in it. And then I'm going to print that out, print the I text strip of that. So I is the A tag, text is the text that the A tag would print out. And that's how I get this list of titles of articles. That's Beautiful Soup in a nutshell. Web pages are messy. Beautiful Soup makes them less messy, but it's still a lot of work. And you could take a whole semester becoming an expert, but this gives you an idea of what's there. And if ever in your career or education you want to do this, go to Beautiful Soup and really you'll have to do a deep dive in it to get much further. So thanks for that, and we'll see you next time.